So another way of talking about x-intercepts is to use the word zeros. The reason why they're the same thing is because it's when y equals 0, you have an x-intercept. So finding the zeros means finding the x-intercepts. Again, it's where y equals 0. And that's what we're going to be doing. Now for this first example, I know it's labeled example 4. It's probably the easiest example, so that's what we're going to do that one first. X. Yeah, zeros are referring to x-intercepts. Actually, I'll go over that with you real quick, and then we'll do example 4. Okay. So, two different definitions for 0. You could just call it an x-intercept, or an x value that makes y equal to 0. They both mean x-intercept. Now, thinking about finding the zeros, now we've already looked at a lot of polynomial graphs look differently. Well, the equations are a lot different too. Because they're so different, there's a lot of different ways to find a 0. It's not one way. So that's why I think I'm just going to do one example a day with you guys, maybe 2 at the most, because every method is different. So let's talk about why that is. Well, let's just imagine if you had a bunch of numbers, okay? So here we have 9, right, times 3 times 6 minus 2, 8 plus 4, whatever. But what we have on the end is 0. So actually, it doesn't matter what any of this is, right? It's times 0. So it equals 0. Okay, the point is, if one of the factors is equal to 0 of a polynomial, then the whole expression is equal to 0. That key word is factors. So what I'm getting at is the way to find zeros of a polynomial is to factor it. And you see when those factors equal 0 is when the polynomial is going to cross the x-axis. Here's another example of the same thing with variables. Notice I just have these numbers. You can choose whatever you want. Let's say this is 1,000,000 times -7 times whatever. As soon as you have a factor that equals 0, the whole thing turns to 0. Okay, so that's why we factor an expression for the most part. Now, like I said, the easiest way is the first way we're going to do it, is just set y equal to 0 and solve. But notice, you know, if you look at all these x-intercepts, what are the y values? Right, because here's the y-axis, right? It's here's y equals 1, here's y equals -1. So you can see that y has to be 0 for an x-intercept. Okay, so let's do the first example, which I know is labeled example 4. We're going to find the zeros of this function. Okay, and the method, which is the easiest method, is just to solve the equation. Now, how do you know? You know, you might say, Mr. Underwood, how do I know if I can just solve it? Here's how you know. How many x terms are in this expression? Okay, if there's just one x term, you can go ahead and solve it. All right, I think there's 3 or 4 in the worksheet like that. So when I give you guys the worksheet, I'll let you know which numbers they are, and you can go ahead and solve those today. But if there's just one x, you can solve it like an equation. You don't have to factor it. Even though technically this entire thing is a factor, technically. Okay. So these are kind of the steps for every single problem, every single example, so write it at least once. But the first thing you're going to do for any time you're finding the zeros is to make sure that it's factored. Okay, and like I said, this problem is actually already factored. Tomorrow and the next day we'll look at ones that aren't factored, and you have to pull out a GCF or whatever. So we'll do some factoring review. So you're always going to look to see if you can factor it first. The next step is to plug in 0 for f of x or y. Same thing, right? And that's what we just talked about. If you look at the graph, it's where y equals 0. That's what an x-intercept is. So we're just going to plug in 0 for f of x. So factor first if you can, and then plug in 0 for y. You can already see why this equation can be solved. We can get x by itself because there's only one of them. So can somebody tell me, what's the first thing you're going to do to get x by itself? Yeah, good. Do the opposite of add 32, which is subtract it. Okay, so that gets negative 32 on the left-hand side when we subtract it from both sides. So now we have negative 32 equals 1/4 x to the 7th. How would you get x by itself from here? Multiply by 4. Okay, why? Because 4 times 1/4 is 1, right? And 1 times anything, so basically it cancels the 1/4. Okay, so multiply both sides by 4. The 1/4 goes away. 4 times negative 32 is negative 128. Final step. When you have an exponent and you want to get rid of it, you have to take the opposite root. Okay, for example, if it was x squared, I would take the square root. If it was x cubed, I would take the cube root. This is the x to the 7th, so I have to take the 7th root. That will cancel the exponent. So I'll just be left with x, which is the goal. Yes. So 7th root of negative 128. Does anybody know what that is? Negative 2. Now, why is that? Because, listen up, if you take negative 2, you multiply by itself 7 times, negative 2 times negative 2 times negative 2, 7 times, you get negative 128. Usually when the root is this big, the answer is probably going to be 2. Because if you take like 3, for example, and multiply by itself 7 times, it's going to end up being a really, really, really big number. Much bigger than that, 128. So most of the time, guys, it's going to be 2 or 3. Most of the time, 2. So 7th root of negative 128 is negative 2. It's negative. You can take the odd root of a negative. It's still negative. So that means that our x-intercept is x equals negative 2. What that means is this function's graph, 1/4 x to the 7th plus 32, crosses the x-axis at negative 2, 0. Yes, the y value is 0. So remember, an x-intercept is a point. I'm going to show you guys the graph of this. Yes. So what he said was, after you factor it, if you only get x equals one number, does that mean it's got one x-intercept? Yes, that's true. And we're going to look at the graph. Here's the graph. And you can kind of see, now if I zoomed out, it's going to be a really, really steep curve, but I zoomed into the x-intercept. You can see it only touches at one point, which is at x equals negative 2.